Alright, this particular pre-cal lesson will kind of summarize what we're going to do for this week. I'm going to go through and I'm going to make one long video. At this point I've gotten kind of to the end of time that I'm going to be home, and so I need to kind of make one long video, upload it, and head out. But what I'm going to do is I'm going to kind of cover this week's plan. And so Tuesday the plan would be to cover these particular numbers. And so this Tuesday we're going to do page 720. We're going to do numbers 20 through 32 even. If you can get that far, I'm going to be pretty satisfied with that. The homework I will give or the proctor can give at the end of that. On Wednesday, okay, first of all, on Wednesday you will have not a quiz, you will have that on Thursday. So I'll put that here in a second for Thursday. Alright, so what are you doing on Wednesday? Wednesday you guys will be covering page 721. You'll be doing numbers 39 through 46. Okay, even. And we'll just put a big E there. And then you'll also be covering 39. No, you will not. So that's all you're going to be doing. And then there is a quiz on Thursday. Big quiz. This is going to be over 10.4a, so the first part of it, part A, that'll be, the first couple examples. And then Thursday, you're also going to have, you're going to be work on this thing called classifying the conics. I'll talk about that just a little bit, 53 through 68. And so those are going to be the problems you cover. That'll also be on page 721, I imagine. Okay, and then moving on to Friday. Friday is again another quiz. You're going to have the 10.4 quiz. Okay, and so you'll have that 10.4b, and that'll be the last couple examples. We'll only go through examples really 1 through 4. Let me go ahead and write that there. We'll have 1 through 4 that we go over in this particular lesson. You'll also do on Friday the numbers, page 722, number 69 through I believe that says 76. Okay, and whatever you don't get done, you will have for homework that night. And so those would be the problems that we're going to look at. So my goal and my task in this particular video is to go through this with you and make sure that you know how to do each example in chapter 10.4 or in lesson 10.4. So here it is. Here's our next part. Example 2 looks like this, and it says, example 2, it says, using asymptotes to sketch a parabola. So it's a sketch the parabola, and it gives, oh, actually, before I ever get into that, I need to give up some preliminary stuff. It says that you can actually find in a hyperbola, remember we said that if you had your foci, sorry, I'm going over here, and then you have kind of another one over here. But remember, hyperbola, you've got your axis, and it'll do something like this. Okay, I'm supposed to go through the two. Let me go ahead and fix that. So you would have a line that kind of goes between them and goes between the two foci. So this is F, this is F. You have your center at the origin. Okay, remember A, by the way, this is the vertex here, V. This is the vertex V. This distance here is 2A, or what's called the transverse axis. Okay, and so A is just simply half of it. Now C, of course, goes from the center all the way over here, so C is this entire length here. All right, now the other direction is to what we will call the conjugate axis. Okay, conjugate axis. And so the conjugate axis is going to be the other part of what you've heard of to be the rectangle. Okay, and so you will notice that you'll go out to here. This is B. The whole thing is 2B. And so you'll have kind of a box that's formed here. Okay, and so you form this box, and then once I get rid of the word conjugate, so there's two axes. You've got your transverse axis and you've got your conjugate axis. Then the diagonals of this are the asymptotes of the hyperbola, and I will talk more about that as we get to them, but that's kind of the main thing. So it says you should actually be able to find the equations of these, and so the asymptotes can be found by using these equations. Okay, let me find my pen here. The asymptotes. So how do I find them? So put this in your notes somewhere, asymptote formula. Definitely want to know this. So it says the equation of the asymptotes, and this is on page 715, can be, the equations are found here. So the first one is y equals, and it says that you're going to use k plus minus b over a times x minus h. Okay, and that's going to be the equation of your hyperbola, or sorry, not your hyperbola, but your asymptotes. And this is going to be only true, and this will only be used if you have a horizontal transverse axis, like the picture to the left. If your transverse axis is, by the way, it's plus minus for a reason. The b over a represents the slope of the line. Going this way, I'm going to try to use a different color here. Going this way, that's a positive slope. Going down would be a negative slope. So you're going to have an asymptote for both directions. So you'll actually have two different equations for this. So one of them will be a positive, one of them will be a negative. And then as we move forward, by the way, the h and k are part of the center of this. As we move forward, I'll do this rest of this in red, it looks like. And so we'll have k plus minus. Notice that's going to be the same thing. But in this case, it's going to be a over b. Notice how this is simply the opposite. And then we'll use x minus h here. Okay. Now that will be only if you have a vertical transverse axis, which is going to be the line that connects your vertices of your hyperbola. Okay, so let's look at example 2 now. I'm going to have to hold enter for a bit in order to get myself going in here. But basically those formulas, if you can get those in your notes, this will be incredibly helpful to you. Absolutely know those, okay? All right, let's look at example 2. Example 2. I'm going to try to get example 2, 3, and 4 in, and then I'm going to upload this video for you. So here's example 2. It says sketch the hyperbola, or sorry, yeah, hyperbola. It says 4x squared minus y squared equals 16. And your immediate thought should be, whoa, hold on, I thought that this should look like x squared over a squared minus y squared over b squared equals 1. That's the way it should look. But you'll notice it doesn't equal 1. It equals what? Okay, so 16. And so I want it to look like the standard form. So what I'm going to do is I'm actually going to divide both sides by 16. Didn't mean to draw that line all the way through. Here, I'm going to divide these by 16, divide this by 16. The right side's easy. That's going to be 1. That'll give me 4x squared over 16 minus y squared over 16. And that's going to give me those values. Now, this will also give me, notice 4 and 16 cancel to give me x squared over 4 minus y squared over 16. There's no cancellation there. So that is my equation. Now, it does say divide each side. From this, you can conclude a couple of things. Remember, a is always first. A was the first one every single time. So a is the square root of that, which is 2, and b is the square root of 16, which is 4. So now we have a little bit more to go on. It does say using this to sketch the hyperbola. So what I'd like to do is so this is my equation, okay, and I need to write out everything I know. So here's my equation, okay. What is the center, by the way? I'm going to start writing some things down. The center, of course, because it's not in a translated form, the center is going to be 0, 0. That's the origin. A value is 2. The b value is 4. Remember, c squared is equal to a squared plus b squared, so that's how we're going to find our c. And so c squared is equal to, that's going to be 4 plus 16. That's going to be c squared equals 20. And then c is going to be the square root of 20. That's going to be 2 square root 5 is c. And so that's going to be important. C is 2 square root 5 because that's going to be the distance to our foci. All right. So now the question would be, since x comes first, is this horizontal or vertical? Well, you'll find that this thing is, in fact, horizontal because x comes first. Not because of the location of a, but because x comes first. So this is horizontal. All right, so we know that, let me get rid of this work here so that we can draw the picture. But basically, we are going to need some axes. And so let's get this portion. Nope, we're going to have to clean it up a little bit, but get something like, okay. Part of this is I'm writing on a screen here. I'll try to make something a little more straight. And so we got something going on here. All right, so we know that this thing is horizontal. And so, of course, we got a center at 0, 0. And from that center, we're going to move on the transverse axis 1, 2 units. Remember, we will make the point here. That's going to be my vertex. Over to the left, we're going to move 1, 2 units. Remember, that's the distance of A, and that's going to be my other vertex. From there, I'm going to find my foci. My foci, actually, I'll show those in a minute. I'm going to find my conjugate axis, and so my conjugate axis is going to be 4 in each direction. So 1, 2, 3, 4, perpendicular to that. You'll notice it's all the way up here. 1, 2, 3, 4, all the way to that. And so in order to draw this, you should get a rectangle. So you're going to draw this upward, like so, and you're going to connect a rectangle that is drawn between all of these. And remember, this horizontal axis is called the transverse axis. This vertical one is the conjugate axis. Neither one is necessarily bigger with a hyperbola, but you'll get a rectangle using these 4 points. From there, you need to construct the diagonals. These are going to be very important, and so if I can construct a diagonal here, you'll notice I get, and I have a feeling those diagonals ought to go through the center. That part of that's just my art ability. Let me change it up so I get it as close as I can. Okay, so something like this. Okay. It should go through the center, of course. It's coming from the top, okay, going through the center, and it's going to do something like this. Well, these are called asymptotes, okay, asymptotes. And so as you draw asymptotes, those are lines that the function gets infinitely close to, okay, hyperbola gets really close to without touching. And so I draw my hyperbola. This is just this curve here, and again, it comes up like so, and it comes away from it. Now, technically, when you draw the hyperbola, you actually can go through and you can erase the entire box now and feel a little better about yourself. Now, the actual asymptotes matter, but the box is just simply used to find them. Now, it did just say to draw it, so sketch the picture. That's what we should be looking at, but the box is used as a visual aid. Kind of help us set this up, okay? Now, let's move on to example 3. Honestly, on the first day, you could actually stop here. You could go up here and do these numbers 20 through 32, do some of those problems together. Maybe come back through and look at some of the example, but that should be enough to get you through. Of course, you've got the answers in the scrolls you can look at. But let's go ahead and move on to example 3. Example 3 is on page 716. Here is example 3. So here's example 3. It says, finding the asymptotes of a hyperbola. So it says sketch the hyperbola 4x squared minus 3y squared. Okay, looking quite a ways across my desk here. Plus 8x plus 16. So plus 8x plus 16. And that is all equal to 0. Okay, it asks us to find something. It says find the equation of the asymptotes and find the foci. So we need 2 things. Asymptotes. Okay, there's 2 equations there, and I need to find the foci. Okay, and once I find those 2 things, I win. All right, you'll notice this is what we call general form, and general form doesn't really give us much info. That's general form. And so the way we do this, remember, is we're going to group things. So the first step is to get our x's together. So we'll get 4x squared together, and we will have 4x squared plus 8x. Okay. And we'll keep the y on the left side as well, because in theory we're going to be moving that, and that is going to equal negative 16. Okay. From there, it would probably be wise to start grouping, and so we're going to factor the x terms, and so we'll get 4x. I'm going to go ahead and leave the x in there, although it's a shared common factor. I'm going to get 4x squared plus 2x here, and that's going to be minus 3y squared is equal to negative 16. Now in a hyperbola, what should that negative 16 be? Okay, sorry, I was already jumping the gun. We don't want to do that yet. We actually want to complete the square, and so let's go ahead to this point where we have our binomial. We're trying to make this a binomial squared, so we'll have 2 plus 2x plus blank minus 3y squared, okay, is equal to negative 16. Now notice, we want to find this blank. Remember, in order to find this blank, we take 1/2 the coefficient of x and we square it. So 1/2 of 2 is 1, 1 squared is added. But remember, what we do to one side, we have to do to the other. And because we have 4 times that 1 over here, we also have to have 4 times that 1, so we keep the equation balanced. All right, from there, we can actually take this 4 and we can factor this PST. The PST factors to an x plus 1 quantity squared minus 3y squared equals negative 16 plus 4 will be negative 12. All right, from there, you're definitely going to want to set this equal to, let me extend the page a little bit more. You're going to definitely want to set this equal to 1. In a hyperbola, that's your goal. So you're going to divide, okay, by a negative 12. Okay, you're trying to make this thing into a 1, so negative 12 over here, you get a negative 12 right here. And so dividing both sides, you're going to get 4 times the quantity x plus 1 squared all over negative 12, plus, because you got a minus, 3y squared over negative 12, okay, equals 1. And so you'll notice a couple things. First of all, that plus isn't okay. I can't have the second negative 12 or I'd change the value. Remember, I canceled the negative here and the negative here, so it's 3y squared over positive 12. All right. So simplifying as much as possible, you'll notice I'll pull the negative sign out front. We'll have 4 and 12 will cancel, so we'll get x plus 1 squared over the negative is pulled out front, so we'll have a 3 left over plus y squared over 4, and that'll equal 1. Now you'll notice in a hyperbola, remember, you want to make sure that your negative is in the middle position, this position right here. And so I'm going to rewrite this thing so that I have it written in the right form. So we have y squared over 4 minus, this is just rearranging the problem, x plus 1 squared over 3 equals 1. Now I have everything I was looking for. All right, going up to the top right, you'll find we can find our center based on what we have. The center of the hyperbola that we just wrote is going to be negative 1, comma 0. Notice the HK form. This is our H. We'll use the opposite sign. We'll use the 0 from this, and we will get our center. All right, from there, we're going to take our center and we're going to find a couple things. But I don't want to do extra work, things that we don't have to do. So remember, the goal is to find the asymptotes. Remember, also, another thing we need to know is this thing horizontal or vertical? Well, notice the y comes first, and so this is a vertical set. And so since we're going to find the asymptotes, I will go to that in just a minute. So this is vertical. Let's go ahead and find A. A is the first one every single time. So A is 2, it's the square root of 4. And then B is the square root of 3 in either direction. We can find C very simply. C squared is equal to A squared, which is 4, plus B squared, which is 3. So C is equal to the square root of 7. So those are the values I get. And you can pause at any point and kind of think through what I've said, but I am kind of making this quick. So those are your 3 values, A, B, and C. From there, we want to start, it doesn't ask us to draw the picture, it simply asks us to find and label the foci. Remember, since this is vertical, we have our center. It may be wise to draw a picture, but another thing that we can do is we can actually know pretty much right now the asymptotes. If I go through the asymptotes, remember, for a vertical asymptote, I'm going back one page to 715. For a vertical asymptote, your formula is y equals, okay, and it says k plus minus a over b times the value of x minus h. Now, the only thing that changes between these is the order of a and b for the different orientations. So this is for a vertical asymptote. And so you're going to have your y value. Y is equal to, that never changes, but the k value from your center is going to be 0. So y is equal to 0 plus minus a over b. So that's going to be 2 over square root 3. And then we're going to have x minus h, which is going to be x plus 1, because a minus from this hk up here is going to be a positive 1. Now, of course, we don't want to leave this as 2 square roots of 3. Actually, I don't even know that that matters because it's actually a slope. But yeah, you can go ahead and leave it there because it matters as a slope. So you're actually going to get 2 asymptotes from this. And I want to show those to you now. The 2 asymptotes are y equals, notice it's plus minus, 2 over square root 3 x plus 1 and y equals negative 2 over square root 3. I'll make sure my negative is obvious. Negative 2 over square root 3 x plus 1. And those are the two equations. This is the negative one, the one that goes this way. This one's the positive one, and those will make your two lines. Now, as far as finding your center, or sorry, your foci, you're simply going to find, because it's vertical, you're going to take your center. You know, the picture kind of looks like this. You've got your parabola doing something like this, and you know that the foci will be these points in front of the two. And so here's your transverse axis to the value here. All right, so you have your center of negative 1, 0. And remember, C is the distance from the center to the foci, the F value, top and bottom. And so what we're going to do is we're going to write our center. So our center is going to be negative 1, 0. And we're going to simply add or subtract our K value, or sorry, our C value. So you can say 1 comma square root of 7. Okay, to find this one, we just added it to 0. So that's going to be this particular point. That's going to be 1 comma square root 7. And then this one down here will be 1 comma negative square root 7. So we subtracted that from 0. But I actually don't even mind if you write it down. If that was a different number, I'll put it down here in the middle here. But if you did like 1 comma 2 plus square root 7, 7, so you don't actually have to do this as a decimal, and then 1 comma 2 minus square root 7. Again, that's not, if you, in this particular problem we had a 0, but you can write that in a compound rational way. And so all of the things that I asked for, here's your two asymptote equations, and here is your, right here and here, there's your focus 1, focus 2. Also, I'm sorry, I shouldn't have had a negative 1 here. That should just be a positive 1. So you're not moving far, you're just giving them label. Otherwise, you can get really technical with this picture. You could find the conjugate axis, you could find the transverse axis, draw your box, connect all your points, and you can get really technical, but all it asked for were two things. Okay, let me get example 5 and we will call it, example 4, and we will call it good. Okay, in example 4, it says using asymptotes to find the standard equation. I'm going to extend this even further down the page. By the way, at this point you could probably pause the video and even give another assignment, see how many of these problems can be done through that. Of course, we're definitely past the material that could be quiz 10.4. Let's move on. So, and this will be the last example. It says, example 4, using asymptotes to find that. So find the standard form of equation of a hyperbola having vertices. Okay, so here's your vertex. Vertex 1, we'll call it V1, is equal to this particular value. So it says 3, negative 5. Okay, and vertex 2, okay, is equal to, in this problem, 3, 1. Okay, and that's our point. And then it gives us the two asymptotes. Okay, I'm going to try to condense them if it's possible. Yeah, I could, but it would actually be better doing it this way. Y is equal to negative 2x minus 8. And then y is equal to negative 2x plus 4. Okay, and it says, find the standard form of this. Well, of course, what they've done, going up here, is they've actually distributed these values, so these asymptotes look a little unique. Okay, and so I'm going to follow along with the solution. It says by the midpoint formula. All right, first of all, before I even go further, you need to determine whether or not this thing is horizontal or vertical. So if I draw my sketch of my axes, you've got 3, 1, 1, 2, 3, going up 1. That's your first vertex. That's vertex 1. Actually, that's vertex 2, and then the other one is 3, negative 5, and so 1, 2, 3, 4, 5, and so here's vertex 2. Okay, this thing is vertical. Okay, so we know it's vertical, and from there we know that our center is going to be the midpoint of the two. So, like I said in the past, we need to average these. So the average of 3 and 3 is 3. And the average of 1 and negative 5 is negative 5 plus 1 divided by 2. So negative 5 plus 1 is negative 4 divided by 2 is negative 2. And so our midpoint is 3, negative 2. So 3 down 2, that is going to be our center. All right, from there, we actually can know a couple more things. Obviously, the distance from the center, 3, negative 2, the distance from the center is A to the vertex. And so we now know that A is from 3, let me write this somewhere helpful. The center is 3, negative 2. Okay, so again, I'm writing down everything we know. Okay, the center is A. And so looking at that particular one, 3, negative 2, A is going to go down. We had 3, negative 2 to 3, negative 5, so the gap here is 3 units. That's all we really need to know about that. Also going up this way, it's 3 units. And so A is equal to 3. Okay, so there's that. So that's what we have so far. Now, furthermore, the hyperbola has a vertical transverse axis with A equals 3. From the original equations, you can determine the slopes of the asymptotes. Okay, so when you write these equations, you got to remember that you're writing this as, all right, y is equal to k plus minus the a over b, because this thing is vertical. So in a vertical one, you got a on top. Just making sure I got this. A over b times the x minus h. Okay, this a over b is your slope. And so you can actually set this up. Now that you know, okay, let me see here. From the original equations, you can determine the slopes of the asymptotes to be. The slopes are simply just the coefficient of x. That's all we're saying here. That's all you were supposed to look at. And so the slope of one equation is, we'll call this equation 1. So the slope of 1 is equal to negative 2. Slope of the other is negative 2. I think one of these is a positive now that I look at it. Yes. This one over here, 2x minus 8, is a positive. I'm sorry, I copied this wrong. So therefore the slope will be a positive 2, and the slope for the other one will be a negative 2. Okay, and those slopes are both equal to this a over b. So you can say the measure of, slope of 1, m1, is equal to 2, and that slope is also equal to a over b. But what of those letters have we just found? Okay, you should be saying b. And so I'm going to say 2 is equal to, sorry, we didn't just find that. You shouldn't be saying that. You should be saying we just found 3 to be a. So we have 2 is equal to 3 over b. If we solve for 3, if we solve for b, we're going to get 3 is equal to 2b, multiplying both sides by b. Okay, and then, of course, dividing by 2, b is equal to 3 halves, or 1.5. Okay, now I can come over here and say b equals 1.5. Now, you'll realize that it doesn't matter which of the equations I plug in to find b. If I plug in the negative 2, let me show you what I mean. Okay, going through a lot of material very quickly, so you may want to go back through, rewind, even see a couple of things. So 1.5 is our b value. If I take the other one, we say negative 2 is equal to a over b as well. Remember, a is still 3. Okay, but we multiply this over, so you get negative 2b equals 3. Divide by negative 2, and divide by negative 2, so b is equal to negative 1.5. Okay, what do I do with that? Okay, so we've got a b is equal to 1.5, we got b is equal to negative 1.5. All you're going to do with that, b is usually just a directed distance, so we care about the positive direction. What we can do with that is we can actually find the rest of the picture. So I don't actually have to, because once I find a and b, I can actually, once I find a and b, I can find c. Okay, and so moving down the page, I can find c. Let's see if I can extend this a little bit. Again, huge problem. Okay, that's all example 4. I guess I never wrote the label here. This is where example 4 starts, example 4. And so this particular one, once you have a and b, you can say c squared equals a squared plus b squared. Don't know that you need this to do the formula, but I'm just summarizing everything. So c squared is equal to 9 plus whatever 1.5 is. I think it's 2.25 when you square it. And so c squared is equal to, it's going to give me 11.25, and then c is equal to, excuse me, here, c is equal to the square root of 11.25 if you so needed it. Okay, there's a, there's b, and there's c. All right, but in order to finish this formula, now that we know this thing's vertical, we're going to say y squared over a. Actually, we're going to, since we know this thing has a translated center of 3, -2, we're going to say y plus 2, because that's our center. Now notice at the top of the page here, we've got y plus 2 squared over a squared, so we know a is 3, so we'll put a 9. Notice the minus sign. It's very important. And then we're going to have x minus h, which, by the way, is 3. And so we'll put a 3 there. We'll square that, and then we'll square b, 1.5 squared. I think it's 2.25. Just checking this to make sure I'm not making this stuff up. Sometimes I do that. So 1.5, you square it, you get 2.25. And then, of course, this is all equal to 1. Okay, so at this point, we have covered everything. This is exactly what you should have as your answer for example 4. This allows you to do a couple more problems. One more thing I wanted to mention is there's also an eccentricity to these, to hyperbolas. And eccentricity is a simple formula. We talked about it in ellipses as well, but the formula is E equals C over A. And so if we use the problem we just had, we have the square root of 11.25 divided by A, which was 3. I put the square root of 11.25 in my calculator, so 11.25, take the square root, I get a really cool number, divide that by 3. The eccentricity of this thing is equal to 1.1, and that's all I have. That's all you have to do to it. So when they ask for eccentricity, you're just going to use this formula right here. All right, so that'll summarize it. You can assign these particular problems, and you can go through and work each of these. It'll take you several hours to get through all of this material. Of course, we got these quizzes on Thursday, we got this quiz on Friday, and you may even have to go back and rewatch some of the examples that we went through. But that'll conclude all of the lessons or all of the examples for 10.4, and you can use the rest of your time to do math problems. So work hard, make sure you understand it. If you have questions, you can definitely ask me when I get back and when we get back to school. I hope you do well. Hope it makes sense. I'll see you then.